All right, welcome back. Thanks for watching. Thanks for sticking around if you're still on the stream after a very long stream. But if not, if you're on YouTube, thanks for following along. Let's jump right back into it, right? So we're continuing DiSco mimo, and we're really doing OmegaConf configurations. We did 2 modules with structured configs. We have 3 more to do, okay? One of them is kind of easier, models. The other 2 are much harder, train and sampling, because they're required. But the good news is we're probably going to end up deleting code, okay? Now here's an interesting one, is the unit. Let's do models, because this one has... It has the main config, and it has one of 2 configs, which could be either, right? And now we're doing this really dumb thing. So how is the user gonna specify which config it is? That's the problem here, okay? Because the user wants to say the architecture, and then we do a post in it, and we actually set a config field. I don't know if this is the best choice though. Is there any way we can unify these? The problem is the unit config is easy. Now there's even another complication though, because these are also tied to training. So the training code will have to, so there's some disentangling to do here. Be very careful here, because these last 4 parameters in NCSN v2 are actually also known during training. These are purely architectural parameters. Then NCSN v2 is even worse, because it needs to be data aware. At least we can make this channels. These are also architectural parameters. I feel like this one is the hardest one actually. There is a trick though. Maybe we don't need configs here. I think it's better if we actually ditch configs here. Yeah, let's do it that way actually. There is a trick here. I think we locked ourselves in the trap here. What we should really say is get a model with an arch, okay? And let's deprecate the let's deprecate diffusers for now. No, let's not. No, let's not. No. So we're gonna match the arch, okay? Okay, and then we're just gonna write 2 more functions, right? So we'll say model is get diffusers model. And this CFG will be either, okay, I know how to do it. So we don't need the unifier then. We can ditch the model config. We can just keep the config, the inner one, right? Yeah. So we don't need the meta one. We just need one of two, okay? So either NCS NV2 or unet config. Now it is true NCS NV2 has to be nested like this. And it is true we will populate its sigma end. But this is fine though. This is still more structured. So now what we need is, so just write two more functions, right? So config will be either this or that. This is how we encode it, right? So it'll be either unet config or NCS NV2 config, okay? And that's it. And if it's a unet to diffusers, it'll get diffusers model of config, okay? And if it's an NCS NV2, it'll get NCS NV2 model with config. So now we just need to write, oh, I see. We need a file name, which is a path. So if file name, we can also load a pre-trained model. Okay, so we need from pathlib path. All right. So now we just need to write these two mini functions, right? So we'll write get, what do we say? Diffusers model, which is pretty easy now, right? It only takes a config, which is now specialized though to a unet config. Okay, and it returns this guy, and it just does model. It actually does literally this thing. We may need to wrap these noise levels. I'm not too happy with carrying them around. So let's just put them here, right? Yeah, and it does a model. And we just need to get NCS NV2 model. Actually, let's call this CFG so it's shorter. And this one is an NCS NV2 config, and it returns NCS NV2 deepest. Now, in general, this returns a torch NN module. Okay, that's the unifier here, and optionally also loads it. And this is all we need to do here. Model NCS NV2 of CFG. Yeah, so the CFG just needs device. Now, yeah, we'll have to, the user will build these, but we can override these from the train app. Just important parameters of them, okay? And I think that's it. So just return model, return model. Now, the only question is, are these supersets of torch and N module? They should be, yeah. So typing should not complain. All right, this is done too. So we don't need OmegaConf here either, okay? Which is good. I think we're down to the big one now, training. All right. This is channels. Channels. Oh, it doesn't have noise levels, I see. Sample size, it does not have sample size. I guess we have to make these right, so from, whoops, OmegaConf import missing. Okay, so we can mark these as missing so users know these are mandatory. Same with these guys. These should not live here at all. Okay, only architecture stuff should live there, because this would otherwise confuse users if we have too many hard codes. Now, the architecture stuff is fine to have defaults, okay? Like these other things, but these other things, no. What is noise levels? What does it want from me? Oh, it is not annotated. Eek. Probably a torch tensor then. All right. So then we're also going to need models. Noise levels is a torch tensor. Yeah, this will be a torch tensor missing. Okay, so this kind of works. Now let's move on to training, the big one, okay? Before we do that though, let me add this. I think it's time we introduce Pyrite, because we need to make sure we're actually gonna need it to guide us here. Okay, so clean up mimo.models. Well, maybe not. Let's finish the training design. No, let's not do it. No, let's train now. Okay, so now this is the big one, okay? All right, so we definitely need this to be a Hydra app, okay? So we're gonna need import Hydra. I think training and CDL are really our only Hydra apps, which kind of makes a lot of sense, because this is the only thing you want users to ever run from the command line. Either data generation, training and sampling. Training, sampling, and CDL, which is literally like data generate, train, and sample. Perfect. So we're gonna have to register configs. Okay, so train config, we're going to register it as train. Oh, sorry, we need config store. Okay. And it's go time now. So now this is not so bad. If this is really the, okay, so now check this out. We cannot carry around 4 configs. Everything we do must be derived from this training config now. This is the biggest constraint. This is the user design, all right? So you want to say this config is train config, and we also want to do this trickery here where we convert it to an OmegaConf thing. And it's a none, okay? So now we cannot have any more trickeries in the main where we cannot. We need to just call main. Yep, no more of these guys. Actually, nothing. Okay, so now our job is to route back all the arguments that we lost, okay? So, this is the wrong comment here. It's not instantiate model. It's... My question to you is, do we need the noise levels? Well, Now, can I reuse some of these? The unit really messes me up, right? Like having two different ones, unfortunately. Also, these devices should be missing. This is really bad here, yeah. So our job is to populate these. So it sounds like we really need subconfigs for them. Could I unpack these somehow? The only thing holding me back is that I need these to be in model as fields, unfortunately. Because of the goddamn... Because I have them here. I have the values here, right? Yeah, noise distribution, geometric, right? We should put them like this. So num noise levels, right? Max noise level, noise step factor, noise distribution. There we go. So these four guys, they need to make their way here. I think I just need an arch then, which is NCSN V2. Or is it NCSN? Oh, it's V2, yeah. And I don't know what to do with these. Yeah, sample size we do not need for sure. Okay, these are training parameters. Okay, so training. Noise schedule. We do not need the two sampling brothers. Actually, we don't need anything here. We do need a save dir, which is missing. Okay. We're pretty much there. Yeah, these we can move here. Verbosity. So the only problem really is how the heck do I get this noise schedule in? And I just have to make it. There's no other choice, I guess. Yeah. And mimo data, I no longer have data config either. I just have get data. And it returns a config. So we gotta be careful there too. So I may need a channel config. Mimo utils channel config. I no longer have data. I don't think I have this either. I just have get model. All right, so let's start reading the code. So noise levels, do I need to create these? I don't know. Let's see. What does get model want? So we should do these. So, configure model or model architecture, right? So let's do it this way. So if cfg.arch, I have to do it this way. There's no other easy way, right? So if it's a unit 2D diffusers, I need the noise levels. Oh, I see. Device, very important, right? CUDA. So cfg.device. Okay, cfg.device. All right. Yeah, we need to create a model, a CFG model, which I have no choice but to do here. Else if and CSN v2. I need to make a model config, and I need to import these two guys here. I need to branch my logic. Yeah, there's fortunately no other way. So from models and CSN v2 config. So this will be a NCSN v2 config with device config device, very important. And I gotta do this thing now where model config dot model dot I have to take this num classes is CFG num noise levels. I have to tie everything together. This is the only way. This is also a hard constraint because of this NCSN v2 repo. Sigma begin, sigma rate, sigma dist. Yeah, I think this is the cleanest way we can do it, right? Yeah, so I'm not going to expose anything else. The activations and stuff, we'll leave that for another time, okay? Yeah, so this is CFG. Okay, this one is easy actually. CFG, 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 very good. And what else do I need to do? Sigma dist, which, what did I call it here? Noise distribution. All right, so we populate these. Now this one is also, it's a unit config. Now why did I put channels missing? No, this is a tool. I don't need to put, this is an architectural thing, right? Yeah. I just need noise levels here. Noise levels. What, and what's the other mandatory one here? Sample size. Ugh. Interesting. I'm gonna have to load the data first then, which is fine. Which reminds me, data. All right, so train data path missing. Val data path or none. No, path is missing too. So I'm gonna need to specify training validation data. All right, so let's load the data then. Okay, so we can get this ahead of time now. we're making our way. We're working our way through all this stuff. Oh, I should really conjugate this actually. And complex conjugate. Right? So sampling what I conjugate to. Yeah, I gotta be careful not to taint this. But yeah, we definitely need this. Okay, so we don't need these anymore. We got rid of 2 lines. Yeah, tensor dataset is fine. Data loader, this is just CFG. Val batch size is fine. Oh, I see. So this is just CFG. Because now get data wants a path. There we go. Perfect. So it's just CFG dot train data. And this is a CFG dot val data. Okay, but also we need train, we get train config. I don't think we need val config for anything. All right, so now we know sample size is train config dot num rx train config dot num tx. All this just to get that. Good. Instantiate model, get model, cfg.arch, and model config. And of course, no file name because we're not loading anything. We should make this ASAP. Okay. Save dir. Okay, we're getting there. We are definitely getting there. Actually, this should work from the command line. We're actually very close to get there. So cfg.lr training loop, cfg num steps, cfg device. And I think this is it. cfg.loss verbose, cfg device. Save verbose, save dir, optimizer. Well, state dict is fine here, yeah. So to object, what? It just gives me a dict, right? Okay, so CFG. And I think we're done. Wow, we're actually done hydrifying the training app, which is pretty impressive. So the nice thing is I have all this now, right? So I can just, let me clean this up a bit. So now what I can just do is very easy. UV run pre-commit run all. Okay, I can just run this. And here's how nice it is, because I can say something like, so UV run group mimo dash m, no, sorry, group torch dash m mimo dot train. And what do we have to say? 3 things I have to say. Save dir is it works. Okay. train data, I have to point it to the file, which is data minus golden slash. This is the nice thing because I can actually reuse this now. .h5 and val data is data minus golden cdlc and val.h5. And that's it. It should all work. Hopefully it works. If not, we'll figure it out. Unable to synchronously. Ooh. Aha, because I did not generate data. Okay, so I need to respect the full pipeline. Very good, very good. So first I have to run group Siona -m mimo.cdl. I gotta regenerate my training data, all right? So what does CDL want? Save path is new data or data new slash train C or just train.h5. We don't need to put that in the title. And I can ask for num samples is 10,000. Because this is train data, right? Okay. So this should save me data new train, 10,000. It's gonna take about 10 minutes. But I can make it even faster because I can say max chunk product is 50,000. This is the nice thing about Hydra, because now I don't have to edit code. Okay, so it should take about 7 minutes. And then I can open another terminal while this is running. I can say the same thing, UV run group Siona -m mimo.cdl. Save path is, what did I call that? Data minus new. Okay. Data minus new val.h5. Num samples. I can just ask for 100. And that's it. I don't need more. Obviously, TQDM is broken as usual. Okay, so we need to document all these. Very good. This looks very clean now. So we have training data, validation data. Where do we put that paper thing? So document the complete user experience with Hydra. Seamless run with UV mimo CDL and save to files. Then seamless run training by pointing to the same files, e.g. allows for environment variables to be used. Finally, run sampling by pointing to the model now. So you get the gist of what we're gonna do next, which we can start working on sampling now. Sampling is also an important tab because it will also need to be Hydraized, okay? So, but we're gonna do a even nicer trick. We're just gonna load. Does OmegaConf have a toDict option, or what is toObject? Oh, it's a primitive container, right? It's a dict. So we should be able to save this, to load it, I mean, which is perfect. So now we're gonna need to Hydraize sampling too. I don't think we need any of these, which is very good, okay? Very good. We do need these. Okay, so these will be critical. They will be R, no, R we can't. We need to use num steps outer. We also need to use. We just need alpha 0. Which, so what do we do with this? We put it missing? No, we can't put it missing, right? We'll put float or string auto. Okay, this one's gonna have a special thing, because if we set it to auto, then we'll do the epsilon thing. If we set it, if the user wants to pass it as a float, they can pass it. It's their problem. Okay, we're gonna have to register the config as usual. But wait, there's more, because we need to know what model are we loading. Okay, so it'll be a load path missing. And this is the only thing actually we need. We're just gonna load the model and it's gonna have all the parameters inside of it. And that's it. So main now becomes obviously decorated by Hydra, same story. And it only has CFG sampling config, right? Yep. And it returns a none. Sampling, and then the big main. Let's do this thingy here too. Yeah, we're gonna have to instantiate the model here. Otherwise, R we can get. Yeah, this is easy enough. So we can't have these anymore, which is how it should be. We just call main. I don't know, where the heck did my functions go? Real to complex, not quite sure what happened there. Let me see what this thing, oh, hang on, quick break. So yeah, we gotta finish this. I think we're close to finishing it though. I kind of want to push through it. Come on, is the data ready? I guess we can start working on this. So it's gonna take a while. Let's unpack the sample from model. Because I need a num steps outer int, num steps inner int. Okay. And we need an alpha 0, an R, and a beta. Float, R, float. It's gonna look, it looks bad, but this is what it is for now. We can't, I don't know how to do this another way. All right. Okay, so we cleared this up because we gotta get rid of all these configs. Sample size, oh God. Okay, so we can't have config sampling anymore, that much we know. I guess the first thing we do is we load the model, right? And configuration. So we say, oh, we have to raise here, by the way. We should check for these. So if not train data is file, oh sorry, self-train data, raise value error, training data file must exist and be generated by mimo.cdl. Same thing for validation. So these are our safety chains. And then for sampling, we also need the obviously the model itself to exist, right? The load path. Model file must exist and be generated by mimo.train this time. All right, so then we're gonna do, let's see. So let's start with the basics then. Let's load the model. So torch.load, cfg.load path, map location CPU. Okay, so what do we have inside here? Okay, nice, our data is done. We can close this. So now I can go back and I can actually train my model. Very easy, right? So group torch, train, save dir, it works, train data. Where do I get the training data from? Oh, it was data minus new, right? Yes, train. .h5 and val data, data new val.h5. Okay, why does it not exist? Oh, sorry, train.h5, obviously, very good. This is why Hydra is good. We just caught an early error, because otherwise it would have had to. So why, whoa, who has a string here? 48? Num classes. It doesn't know how to cast this or what's happening here. Did I? So what? Num noise levels is not. I know what's happening here. We cannot delegate this on missing stuff. Oh yeah. So we're gonna have to do it on the fly. Yeah, it is what it is. This one is bad actually. Sigma end is model config.sigma begin sigma rate num classes. Yeah. Oh, I see. So we can put the sigma end float missing. Not too great here what's happening, but this we're forced to obey Yang Song's framework, which is, it looks bad, but this is the cleanest way to do it probably. All right. Again, we can try to train again. So now we have the it works folder. Let's see. Model get model. Oh, file name is okay. I just need to clean that up. So file name, path or none is none because we want that to be optional. Very close. We pretty much got the model. We're close to training and we are done. Cannot access the noise level. So train. Very good. So where's length noise levels? So this is a mistake because it should be cfg.num noise levels, right? Ika, we have a problem here. Well, actually, let me override this then. Let me just noise levels. So maybe I can always do this then. The problem I don't like is that the Yangsong code does its own noise levels. On the inside. So now I have a duplicate here. Actually, can I rely on the other one then? So if I get a unit with a wrapper, I'm just gonna call this sigmas. I'll do a trick here. So now I can always reference model.sigmas, okay? So now we go back here. Very good. So we don't need to carry 2 copies. And Yangsong becomes ground truth with this one. All right, so now I can say, so where was I? I cannot reference noise levels anymore, but I can reference model.sigmas universally now. Yes, I can. Because it's either that or that, so it should be. All right, good. I can directly pick from these, which guarantees correctness, which is also better. Anywhere else is noise levels. Again, this multinomial junk, which I don't need. CFG.device is better. Length val samples, CFG.device is better. Model sigmas. Do I reference noise levels anywhere else? I do not think so. Very good. I think this is the shortest this code can get. Yeah, this is pretty clean at this point. Well, we can do some more trickery with the validation, but this is probably it. There we go. So everything trains exactly like before. And finally, we can finish the sampling now. So where were we? So we load the contents. I really need to wrap this logic in get model, right? So what do I really need here? These 4 guys and the device. Yeah, this is the real get model function then, okay? Because what I do now, so I can save a lot more lines here. Very good. Okay, so even better. And we're pretty much done, right? So what I should do here is I should not take a config. I should take a config. Ugh, hang on. So why can't I do these on the inside then? Very smart. Okay, so I just need to actually do these. And I can do my own config here. Right. And then what do I do? Exactly. Then I call get diffusers model with the config I just made for myself, right? There we go. Very good. So now I just need arch, and I need the 4 arguments, the primordial ones, which are max noise level, float, noise step factor, float, num noise levels, float. I also need num rx, int or none, none, num tx, int or none, none. Device, str is CUDA. So device, let me start peeling these off. This formula, I need numpy here. Very good. So I just need a max noise level times noise step factor, noise levels -1, lin space noise levels, good. I can actually clean the formula up too, probably. Num rx, num tx, and that's it. So I just created my own model now on the spot. I don't need to carry all that junk with me. The other one is this one, which also creates my own model on the spot. Okay, so it does model config, device, num noise levels, max noise level, noise step factor, noise distribution. String, geometric. This one's an optional. Okay. And I get an NCS-MV2 model. Boom, boom, boom. Perfect. All is self-contained. I don't need to do anything. Instantiate model. So now I just get a model. I have to pass all these. There's no way around that. But it's fine. Okay, so CFG arch, CFG, max noise level. Whoops. CFG dot num noise levels, noise step factor. And I need 2 special ones. Num rx is train config dot num rx. Num tx is train config dot num tx. This is just for the UNet. And I am super done now. I don't even need, wow, I don't even have numpy. I don't even need these 2. Let me see again. UV run pre-commit run all. Oh shit, I messed something up here. So what's happening here? Undefined name, CFG train in sampling. Oh, I see, I have sampling problems, right? Many sampling problems. Okay, but besides these, do I have train problems, or is Yeah, there's no way we can make this even cleaner than this. Like, this is wild. Like, I even managed to crunch this line down. All right, so let me delete it works. And let's train again. There we go. Let's see, any issues? Come on, no issues. Bingo. Good, finish sampling now. So we have all this. Let me go back to sampling. So where were we? Finally, I load everything. Instantiate model. I can do exactly what I wanted to now. I have to get data first. Okay, so I'll have to get data. Validation data, okay. So then I can say train CFG is contents CFG, okay. So I'm gonna reference I see, so sampling needs a model path, data path. Okay, so model path. It needs a data path. Data file must exist in generated CDL. So sampling is the great unifier. Good, 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 good. So we load the model. Then we load the data. What do I have here? CFG. I guess I need a batch size. CFG dot batch size, just to get a batch of data. Where do I get data from? Get data. Okay. Next, come on, we gotta make our way through this fast, fast, fast. All right, so I have CFG train, I load the data. Now I get a model, but I need it with the train config. But also with the val data config, be careful, there's a hybridization here, which is very good that I split here, right? Because I need a val config. So now I can actually test the model cross data too. There's no way it's gonna get cleaner than this. So yeah, I don't need to do anything here. I just need to get it and set it to eval, and this will be val config now. But this will be CFG train. Okay. So then I just need get model from models. Okay. Next, come on, let's go. Model eval, I set it to eval. But where do I load the weights? Very important. Load model weights. Model dot. Actually, I should do this after. Load state dict contents. Model state dict strict is true. Good. Compute recommended epsilon. If config dot alpha 0 is auto, else epsilon I guess we can do it this way. Epsilon is config.alpha0. Well, no, we should do it with else here because the typing will yell later. Else epsilon. So if the user wants to put their own alpha0, that's their problem. I know it took us like 1 trillion years to figure that out, so. All right. Else if type alpha0 this is gonna yell, but it's fine. Very good. Model sigmas always. Sigmas. Now we don't need sampling config anymore. This is deprecated. This is a deprecated object, right? Oh yeah, it's not gonna work like this. Right. So we have alpha0, R num steps. Okay, so we're very close to the, we're actually close to the, there we go, synthetic data, finally. Sample from model, what do we need? We're gonna have to carry all this shit with us. It's okay, it's not the worst though. Okay, so what do we have here? Model. There's no more CFG sampling. Noise levels are model.sigmas for sure, but we'll see after. Actually, let me just delete all these. So, just gotta be careful one last time here. Okay, so what do we need in sample for model? Here we go. All this shit. Num steps outer. I think this is just CFG.num steps outer. It should be, right? CFG.num steps inner. Well, this should be length. We can't support anything else, so it should be length model.sigmas. Alpha0 is actually called epsilon. R is actually called. We cannot change the R. We have to use train CFG dot. What is it called though? CFG dot train dot. How do we call it? Noise step factor. We need to use this one. There's no choice here. Beta, it's our CFG dot beta. Noise levels, it is model dot sigmas. Dot CPU dot numpy, I guess. Batch size is, I believe this is our CFG batch size. Yes, CFG batch size. And the trickiest one, sample size, tuple of ints, is we have it here. Okay, I almost made a critical mistake because I forgot that our alpha0 is epsilon. Is epsilon 0. Oh, no. It's not. Actually, our alpha0 is times this. Very careful here. It's epsilon times this. We should do it this way. Alpha0, epsilon is this. And alpha0 is this. Otherwise, alpha0 is epsilon times this. okay? And then we can just say alpha 0 is alpha 0 here, so we don't do a big ass formula. So we just have to clear this up. So what do we have here? And what do I have not? I guess I have to pull the samples hard here. Val samples is next iter val data loader 2. Okay. Oh, actually, this is good. It's config train, right? Yeah, okay, so we're done with this. Now, it is true that our sampling takes more, but it's fine. Where do I have an error? Do I have an error? Sample size. I believe this is val config dot numrx val config dot numtx, and this should be it for good now. All right, so what do we have here? It works. Step 999. Okay, we're done. UV run, pre-commit, run all. Okay. Again. We also have a save location. So save dir path missing. Okay, so we don't need to do all these shenanigans here. OS make dirs cfg.save.dir. So we do cfg.save.dir. It's gonna be tight, but this is it. Let's see it. Final one. UV run, group torch, -m, mimo sampling. What are the 3 parameters I need now? They are model path. It works / waits step 99 pt. Very good. Data path. Data minus new val.h5. Save dir. Samples. Final. A few quirks probably. Let's see what's happening here. So I can't load this shit? Ah, god damn it. I guess from mimo.train. Train config. I have to do this. Yes. Yeah, sure. This can be our own device, CUDA. Because maybe we want to run on CPU, I guess. Oh yeah, num steps. Oh yeah, there is no num steps outer, right? Yes, there cannot be because we can't support the different one anyways. device. Where? Very close. Very close. Wow. 200. Ah, fuck it. cfg.device. All right. Yes. All right. Another one. We gotta figure out this saving because it seems like I need the data class, which is not good. To sampling. Oh, we're very close then. 203. What does it want from me? So, sorry, what is val samples then? I don't understand. Oh, is it like a tuple thing? I think it is. I think this data loader thing gives you... Yeah, it's 0. Some weird thing. Oh, the problem is I can't run pre-commit because it'll delete my... Ha! This is so funny. Actually, I can annotate it like this. Okay. So now I can run pre-commit, which is really hilarious. That's a way to trick the typing system. Okay. So what does it want? One more thing, finally. Who is on CPU? Oh, obviously, 2. The data is on CPU. And now that we're here, let me just look at this sample size too, and we're actually done for good. Wow, this is gonna be insane. I believe I got this wrong. It should be numtx. Yes, I'm pretty sure. What am I supposed to do with here? Like int? Huh? So I can't use this shit? Well, how do I... What is val config? Ugh. I'm just gonna look at the val samples. Forget about that one. Shape -2. -1. There. And do note that I made a mistake, I guess, with the thing there. So this should be a 64 and a 16. That's the data we agreed on, right? This has got to be it. This is the last thing. I really want to see those samples on disk. Noise levels.device. Which one? Ah, okay, so I lied. So noise levels does not have to be a... Oh, it's not a list of float. It's a torch tensor all day, every day, right? Yes, it is. A torch tensor all day, every day. So then I just don't have to pass it. It's just model sigmas. Yeah, there's a lot of redundancy. I can cut maybe 1 or 2 arguments there, but I just want to see it work. Come on, come on. Oh, the logging is broken now. Wow, this is like ridiculously close to working. Because why? My noise standard deviation is now... I guess it always was. Item, right? How the heck did I ever... I don't know. Wild. Can I actually sample from this? Ay, 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 ay. Who the heck is a double now? How is something even possibly a double here? Because I get the validation loss, don't I? Current dot D type. Uh-huh. Did I not pass? Whoa, 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 whoa. So step size is, what is this? Ah, step size is a double, duh. And why is step size a double? Is it because alpha 0 is a double? Interesting. D-type, torch, float 32. I believe it is because of that stupid thingy. Okay, all right. Again, at least I'm fast with this. Maybe run pre-commit, run all. Okay, it's sampling. Oh my god, if this sample does not look nice, then we're back to like... That's not gonna happen, right? I'm gonna lose it probably. Because after all this rework to try and deep... Nah, but there's no way, right? Like, come on. It has to work. It has to work. This is it. Well, this is actually pretty wild. Like, we did a major rework in like 1 hour. It's kind of the point of the clean coding. Come on, come on. Just sample and do the thing. Of course, it's gonna crash when saving to file, probably. No, maybe not. Okay, samples final. Yes, that's it. We're done. There they are. Perfect channels. Okay, so everything has been hydrolyzed too. So everything is now perfectly controllable from command line. I don't have to edit one line of code ever. Woo, we're done. Oh my god, this was pretty wild. Mimo star.